I need to learn the theory. I understood that the tools that we had back then didn't really allow you to do a lot of stuff if you didn't understand the underlying theory. And so I put myself into the mission of like finishing high school and then going to university where in my mind I was going to be doing the things. So, but I didn't consider myself a maker. I kind of put like that whole thing on hold until I finished university. When I suddenly was like, okay, now I did everything society wanted me to do, and I can do whatever I want to do.
This episode of Behind the Tech features David Cuartielles, the co-founder of Arduino. David has been a true pioneer in the open hardware movement. His work developing Arduino paved the way for countless other open hardware projects. And we can count him amongst a small group of individuals whose work established open hardware as the force that it is today. As we look to the future of open hardware standards, like PICSOC in the drone industry, it's invaluable to understand the foundations laid by the innovators like David. His insights on Arduino's journey from a learning tool to a global phenomenon will offer important lessons for nurturing open source communities.
Okay. Hola, David. Can you tell us who you are and where are we?
Yeah. So I'm David Cuartielles, co-founder of Arduino, but also I'm a head of the Interaction Design Master's program at Malmö University. And right now we are at the Arduino office in Sweden, in Malmo. And we are at what we like to call the turning torso room, because you can see the turning torso through the window.
And why Malmo?
Well, I moved here because the university, when it was created, it had a big budget for the arts, and they were developing an art project with an artistic duo called Mikkel Kvium and Christian Lemmertz, and they were making a really crazy thing. They're taking like Finnegan's Wake, James Joyce, the James Joyce book called Finnegan's Wake, and they made like an 8 hours long movie out of it. It's like the book is impossible to read in one run. It's like it's made of like super short sequences, and these guys made the analogy that it was like making a very long movie out of like a collection of short 3 minutes clips that were like cut and mixed together and remixed in multiple ways, and so they made this movie and they were like, we would want to put this on the internet, and 1999 nobody had ever done anything like that, so it was really hard to find anybody with the courage to try to test that material. And I was living in Germany. I was designing chips for Infineon. And I was young and unexperienced. I said, like, yeah, I can do this. And so I ended up coming to Sweden to do this project. And the University of Malmo, that was financing this project in part, they offered me a job on the spot to become a teacher in programming for designers, which led to become a teacher in electronics for designers, because I very quickly understood that embedded technology was coming to change the world, the way we understood our relationship with sensors and actuators. And I managed to convince the management of the school to create courses on that subject. And that gave birth to like what I like to call Arduino's grandfather, which was a word that we made and so on. Well, yeah, I kind of like solved the whole interview in one sentence.
Yeah.
Great.
So tell me about yourself. Like, do you have any hobbies? Like, has Malmo actually helped you develop as a person?
Yeah, well, when I came here, I thought I was going to stay here for 6 months. At the end of that 6 months period, I ended up buying an apartment and stayed. I realized Malmo was a great place to be a base camp. It was extremely cheap. It was a lot of young people. I was 25 years old, and it was great. You would walk down the street and there would be a party in the fourth floor. They would invite you from the balcony, and absolute strangers, just chip in and have a good time. And so I realized that, Malmo was a place to be. And when it comes to hobbies, like I have had plenty of them. Like this is Sweden, so in the winter you need something to do. But my latest, I started like when I finished my PhD a couple of years ago. I asked my professor, what should I do with my life now? And she said, like, cycling is a good thing. And I picked up on cycling again. I used to cycle when I was like 18, 19, and technology in cycling has changed a lot. So it was both absorbing from the physical perspective, but also in the technical perspective. You had to relearn how bicycles work. Like now you have discs and you have hydraulics and electronics, and so right now a bicycle is like a crazy machine without computers, and you have to really learn how to build it, how to maintain it, and so on. So yeah, I use a lot of time on bikes and fixing bikes and talking about bikes and so on.
When did you discover you were a maker?
Yeah, that's a very interesting question that I get often, and I don't have a canonical answer to that question. But what happened when I was a child is that in my family there was no real understanding of the term like spare time. Like many families in Spain, everything was kind of like programmed to a schedule. We were going to school from 7 in the morning to 6 in the evening, and then we'll have like after school activities, and then you will make it home to more or less just go to sleep. So there was not this kind of like empty creative times that kids experience nowadays when they go to school only in the mornings, for example. Um, so I was always willing to do stuff, but I couldn't really do much. But when I was 9 years old, my parents got me a Commodore 64, and I learned how to program very, very quickly. I didn't know any English really. I knew German because I was studying at German school, and I had these manuals in English. And somehow, like with like the user guide was in Spanish, and then the programming book was in German. I sorry, in English, and I kind of figured out what it was saying, and I made up my own programs, and it was written in BASIC, and I was taking notes by hand because I had no printer, and I only had cassettes, and it was real hell to load games or what I was programming on cassettes would take forever. Um, and then when I was probably 14 or something, I made like was interested in how to make my own LED display for my Commodore 64. So in a magazine that I got from somewhere, I saw how to make an LED display that you could connect to like the joystick port. So I bought the parts. I etched a circuit at my home, at my parents' place. I hid this bucket with acid in a locker, which hinges I destroyed because of the fumes coming from this bucket. And the PCB broke my computer because the capacitor was backwards and some other things that I didn't know because I had no idea about the theory, right? I was just building stuff. And so that kind of like set me back a couple of years where I said like, I need to learn the theory. I understood that the tools that we had back then didn't really allow you to do a lot of stuff if you didn't understand the underlying theory. And so I put myself into the mission of like finishing high school and then going to university where in my mind I was going to be doing the things. So, but I didn't consider myself a maker. I kind of put like that whole thing on hold until I finished university when I suddenly was like, okay, now I did everything society wanted me to do, and I can do whatever I want to do. And then it's when I started doing like electronics for art projects and so on. So yeah, in a sense, I kind of like opened that door and then I closed it very quickly and then I came back to open it big time when I was like 24 or something.
So we were talking about generational change over lunch. Do you think the maker movement has evolved and changed from when you started until now? And if so, how?
Yeah, so there is a maker movement before somebody called it a maker movement. And back then, there was a lot about really mastering the technology. And there was a mix between like almost obscure documentation that we will access to through like magazines and so on. And me being in Spain, in like a second class city in Spain, where I come from, it was really hard to get access to a lot of stuff. So it wasn't really until I made it to university and they got access to the internet for the first time on very old Mac computers. I started to discover this world of like where information was being stored and how to access manuals and other things that will open other doors. So that was it. That was like this first generation where you had to really, somehow get access to information in an absolutely non-mainstream way, and it was kind of hard, but at the same time, people were ready to pay whatever to get stuff imported from other countries and so on. You fast forward 20 years later, when the maker movement shows up, it's exactly the time we were breaking the first Arduino. It was the same year. So what happened is there was an emergence phenomenon all over the world of like these different people that were probably had inherited this, or that had been present at this moment where technology was kind of obscure, that had probably like me gone through studies and then realized this doesn't need to be so hard, this should be much easier. And I think that's what gave birth to the maker movement, where we started to look at simplified workflows for really producing things in every aspect. Like O'Reilly at the same time published Make Magazine and Craft Magazine, and putting aside the very strong gendered approach that they had at that time and is strongly criticizable today, they really look at, there's some people that are interested in more like the crafting aspects, and some people are more interested in the electronics and building aspects. So in the end, both of these things merged, and the Craft Magazine disappeared, and everything fell into the Make Magazine. That was about everything. So that's interesting, because I experimented with these to then, it was almost like an A/B testing, like craft versus make, what wins, and make won because craft had other connotations, and yeah. So I think that was like the second wave, and then there is a third wave that is when these things have been commoditized and now it's an experience you can buy, because make was still like documenting things people were doing. But then these things became kits and packages, and there's this commodification process, and that expands into this third wave. And now we hire Arduino kids that come and tell you like, oh, I bought this Arduino kit, or my father got me this Arduino when I was 10, and that inspired me to study engineering, and they apply for a job here, right? So that's kind of like a third wave of people that never really experienced that first phase, that they grew up already getting access to just these oversimplified tools that make things much easier to get started with, but also they got things packaged as an experience. And so that makes me wonder, of course, it's inevitable to think whether these different generations, because I have these different points of departure, and they have these also different expectations of what to get. Because when you build the kit, you're expected to see the kit in, running. Whether we also don't really just like have been departing too much from the original idea, right? That it was really like gaining knowledge on things and trying things out. So even that message have been also been commodified. When you go to like a maker event, we talk a lot about sharing, but not necessarily it's the same kind of sharing that we were talking about in the beginning that gave birth also to open source software and free software and so on.
So you have a long track of being helpful and supportive of others. You practically helped make this platform that is, what as you're describing, like a basis for the learning for the new generations. Like, why do you do this? And what do you like about teaching others?
Well, that's a very personal thing. Like, my first job when I was 14 was to be a teacher to other kids. Everything started because a classmate of mine was having a hard time with math, and I taught her math. And to be fair, I was kind of hoping for a date. I didn't work. We're still friends, but she paid me with a pair of socks because her mom had a fashion shop, and she said like, your socks are terrible, because I was only wearing these white socks with like this blue line on top. And but that was a learning lesson in very many ways. One of them is obviously that I realized that when I was explaining things, I was also learning a lot, because I was forcing me to try to simplify not the content itself, but the way to access the content to a way that other people will understand it. So I had to put myself in somebody else's pants and try to explain things in a way they would understand it. So when people heard that I was good at teaching math, one of my teachers told me that there was another girl in 2 years prior that she was having some problems with school, and her dad had asked for like a math tutor. So I became a math tutor and physics and German and I don't know, 5 or 6 different things to this girl. It was great. They paid me fantastically well, and I realized, well, not only I can do this good, but I can actually be paid for it. So that became my business. So I started to teach and became kind of a job. So throughout my studies, I was earning quite some money working as a teacher. But also I was challenging my teacher. So at university, I realized that, well, this is for people who have studied communications. And there is this tradition in computer vision when you study about the FFT spectrum of an image. They always put you this picture that in Spanish we call La Pamela, which is this lady that is wearing a hat. And it's actually, I think it's taken from Playboy. So it's like an old, just like a head shot of somebody. And it's impossible to understand anything of the image spectrum of an image of somebody. It's like when you look at the sound spectrum of a sound, it's very easy to see low frequency, high frequency. That has a meaning. It translates into something everybody can understand. But when you look at an image where there is it's a complex image, it's really hard to understand what we're talking about. So I suggested my teachers wanted to use a chessboard where you change the size of the squares in the chessboard and then analyze the spectrum, because then you can really see, like, it's a higher frequency because the squares are tinier. It's a lower frequency because the squares are bigger. So I was challenging my teachers already at university about that. So I realized that I really like teaching. I also like to create content for teaching, and I realized back then I have to become a professor at university. So it was like kind of like my goal. And I achieved it when I came to Sweden, basically.
Would you say this was one of the reasons that you co-founded Arduino, or you invented Arduino?
Yeah, definitely. Like I started by teaching programming. Then I proposed teaching electronics because I anticipated that electronics was going to be a big trend in design. And then from that, we created our own board because we had to make our work more systematic, because in the beginning we were teaching 15 students, but there were going to be 20 students and then 30 students. So for me, it was very important to have a system that would help me make my teaching easier. And then is when I was invited to come to the School of Interaction Design in Ivrea, Italy, where I met my partner Massimo. He was trying to do the same thing. Different people in the world were trying to do the same thing, like create a tool to teach people hardware in a design world. And we put our ideas together, and that became the first Arduino board, really. So it was definitely this idea of having this willingness to teach things in an easier way that gave birth to Arduino.
How did you go from Arduino to running a lab?
Well, I mean, once you have something like Arduino running, you continue to. I mean, if you're interested in innovating, you will have to figure out which is the right form for doing that. And having a lab is a very natural way to continue innovating. It can host many ideas and can use it to do many different things. So currently, I am running a lab at university. It's called the Full Stack Lab. That it's bringing together labs in engineering and design. And right now it's kind of like a virtual structure on top of all of the other labs, but the goal is in 5 years' time make a single lab with a proper space and all things. And then here at Arduino, I'm running a very simple electronics lab that's used to conduct European research projects. In particular, we're looking at creating green PCBs, like electronic circuits that can be recycled using microorganisms or worms that will eat out the plastic, and so you can recycle the copper out of the boards. So yeah, to answer your question, basically, if you have an interest in creating new things, you need a space for that, and a lab is a perfect space for that.
So in open source and open hardware, there's often an imbalance between what the open project offers and what the commercial adopters take or want or even need. So was this challenging when Arduino started?
When we started, it was hard because people didn't understand this idea of having an educational tool that was so strongly based in engineering. Then after 3-4 years, I take off, became very meaningful. Everybody understood it, and we started to see competition. And that's interesting because that means that the idea wasn't that bad, you know? It's that people weren't used to it, and getting used to this new concept was hard. But then there is a second facing this. After running Arduino for many years, we realized that many engineers were using Arduino, but the reason why they were not using it in production is because they thought it was not strong enough to do certain tasks. So we started to create what we call the Arduino professional line, which is more oriented towards engineering missions. So we have PLCs and we have like super small boards with computer vision or AI recognition of sound. So you can imagine that there's plenty of things you can do. We have more than 60 boards in the Arduino portfolio right now. So yeah, there is two moments in history where it was kind of hard to reconcile this idea. The first one is like, oh, this is too much engineering, and the second one was, this is too little engineering. Which is, it's funny because it has just to do with the audiences, because the first audience were art and design students, the second audience were engineers. So, but funny enough, the first audience just loved it, and it ended up in every university in the world. And now, if they're not using Arduino hardware, they might be using an Arduino software with somebody else's hardware just because of the ease of use.
If you had to start a brand new open hardware project in 2024, how would you do it?
So I think it's famous, the challenges we faced at Arduino when our company was like at the edge of being cut in half. So I would first ask my partners to sign papers big time. Like I have a tendency to really trust people, but in business you should only trust contracts. So yeah, that's my first learned lesson. On the other hand, I think that open hardware is now more meaningful than ever. For example, the CERN has finally taken the step of really moving into open hardware design tools for good. So it's really a sign that things have matured enough so that we can really make use of pretty good open tools. So yeah, if I had to start again, I will first of all make sure everything is contractually correct, and that's very clearly explained to the community. Also, we started Arduino 19 years ago. So 19 years ago, there were very few open hardware contracts, and definitely none that anybody really could speak about and understood. The arrival of 3D printing really brought a better discussion about open hardware, so people could understand that hardware is not just the electronics; it's also like anything you could manufacture, and brought to everybody's attention the need of having this idea of like contract, which is basically license models that make it open for everybody. So yeah, so now we're in a much better place. So it should be no problem to really start a project, because then we don't need to discuss how do we license this, which happened to us. So we just need to say like, oh, let's take the license from CERN 1.3, for example, or whatever latest version there is, and we can start from there. So it's much, much easier.
So Arduino is being used practically everywhere in electronics, but where do you see it going as it relates to robotics?
Yeah, so Arduino is used a lot in robotics as a peripheral, like the traditional Arduino maker boards, because it's so easy to just hook up a motor controller and make a simple firmware and make it do whatever you want. And that's the proof. Like you look at many robotics competitions for secondary and high school, where they want to work with open tools. They use Arduino Uno. Actually the old Arduino Uno boards, because they're so easy and so robust, right? At the same time, the new technologies we have created really allow you to do a lot of other things. You can have, for example, some of our Nicla Vision boards that weigh, something like 10 grams or something, that are the size of my nail, that have a camera and can do computer vision in real time, 25 frames per second. You can build a sensor that detects a specific thing very quickly, when before you will need like a full laptop with a webcam and so on. So now robots can actually be much smaller, much lighter, and achieve a lot more with technology that is very affordable and using intelligence on the edge. So Arduino is definitely a tool that can help you do things like that.
Lastly, how do you think the aerial robotics community can help, and where can they learn more about your projects and your team?
Mm-hmm. Well, I think the drone community has done a lot. I mean, for example, the arrival of Autopilot was very important. It really put flying unmanned vehicles in everybody's mouth. It opened like a very important part of something that we were just imagining could be possible to something that could be realized. Now, when people talk, for example, about smart agriculture, there is no doubt there's going to be a drone involved. So it's like so. So I think the drone community has already done a lot, and not only the drone, but also the low orbit satellite community has done a lot. So there's already a lot of big contributions there. But if I think more specifically about like which is like the link that you have to Arduino, for example, like in the past, like the let's say the grandmother of the boards for flying vehicles was Autopilot, right? That was a mix of like this reliable small size hardware with like a pretty well designed firmware people were using quite a bit. Um, I would like to see things like that ported to like newer devices that are designed for industrial environments. We have, for example, I don't know, the Portenta H7. That's a board we designed with a European project that has dual core. So you can have like one Cortex M7 doing I don't know, computer vision in real time, and the other one doing like low level control of the flying device. So I would like to see more of these like boards that are a lot more powerful, ported to this environment. Because the moment somebody takes the first step, it's going to be very easy for people to pick up on this and develop more things. So I think that the next steps really are that very likely, because there's going to be more and more powerful boards, what I think would be beneficial for the flying unmanned vehicles flying community would be to remove the old Arduino Uno or the Arduino Nano and just make a socket for like a Portenta board, for example, that has, I don't know, 160 control pins, but it's the size of like a bit bigger than an Arduino Nano. And then you can have a full computer flying that weighs nothing. So I think that should be a very good next step.